Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is rectangle coloring. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given a rectangular fence of length m and width w. Now the fence has four sides. So the total length of the fence is 2 cross L plus W. Now we have exactly enough paint to paint the entire fence using three colors, that being red, green and blue. Now, let's say the total point available to us of each color is RGB respectively. Then R plus G plus B is exactly equal to 2 times L plus W. That is the total length of the fence. Now, each unit of paint can cover 1 unit of the fence. The painting cost that we define is that each side of the rectangle must be painted completely. Now, the side may be painted using more than one color. Now the cost of painting a side is equal to the number of distinct color used on that side. So let's say if on a side we use simply red, the cost of painting that side is 1. If we use red and green, the cost is 2. If we use all three, the cost is 3. We need to determine the total minimum cost required to paint the entire fence. So for the input format, we have t test cases, and for each test case on a single line, we will have 5 spaced integers. These will be L, W, R, G, and B. For the output, we have to output a single integer, that is the minimum total painting cost. As for the constraints, number of test cases will go from 1 to 10 raised to 5. Length and width of the fence will go from 1 to 10 raised to 9. The unit of paints that we have will also go from 1 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, the fence has a length of 6 units and width of 3 units. So of the, the complete length of the fence that we have is on both the lengths we have 6 and 6, that makes it 12, and on the width we have 3 and 3 6. So a total of 18 units is the total length of our fence. Now we need to start coloring with it. So the red color available to us is 9 units, green color is 5, and blue color is 4. So what we can do is, in this fence, if each side has a single color, the total cost would be 4. That is the minimum. But if all the sides have 3 color, right? So the cost of each side would become 3. So the maximum that we can get is 12. So our answer will always be between 4 and 12. And our task is to find the minimum possible. So in the first example, what we can do is we can try to fill each side with a single color as much as possible. So we first fill the width of 3 with red, then the width of 3 with green. So now both these sides only cost us 1. Then we fill the first length of size 6 with red. This also cost us just 1. But the last remaining length has two colors, that is green and blue. Therefore the cost is 2. So total of 5. That is the minimum cost that we can achieve. Remember, we have the exact amount of paint that is required to cover the complete fence. We do not have more, we do not have less. So for this first test case or the sample input, the answer is 5. Let's see the second sample input. For the second sample input, the length and width both are 4, and the color available to us is that red is 4, green is 8, and blue is also 4. Now we want to have a side a singular color as much as possible, and that is possible in this case. We can cover two sides with green because green is exactly 8, so both the sides have a cost of 1. And for the other two sides, we have one as red and one as blue. So again, the cost is minimum, that is 4 here. Let's see how we can approach the solution. So if we see, the number of ways that we can color is pretty simple to get. We have green, red, and blue. Now, what are the different colors that we can use? So only these three. We can change their order, but we don't have any more color to add. So let's say you can go in the format that first you will use green, then you will use red, then you would use blue. You can again choose to do something else. You can go with RGB or whatever permutation that you like. What about the sides? Let's assume that we have something like this. In this case, we are assuming that length is the smaller one here. If it is not, we will simply swap them. So this is the length that we have that we want to color. Now we can choose to go first cover both the length and then the width, or you can again choose to cover some other permutation. Let's say you want to cover the length first, then a width, then a length, then again a width. Since we have the exact amount of paint that is needed to color the fence, the choices are very limited to us. We can start with a color, and since we want to make sure that one side has a single color, if that is the case, that would be best for us. So simply what we can do is we can go over all the permutation of lengths and try to see if we can color them with RGB and its different variations. And whatever is the minimum cost given to us, that would be the answer for us. So for example, in the first sample input, we can say that the first thing that we want to do is, in this case as we saw, we first cover the first length, then the second length, and then we covered both the widths. Now the color choices were, we can go with red, green, and then we go choose with blue. In similar fashion, we can just go over all the permutations that we have of colors and then we have of lengths. In this manner, we will get our answers for each iteration, and whatever is the minimum, that will be the minimum cost to paint the entire fence. And that gives us the solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve, and solve will take the input of LW, the length and width, and then the colors RGB. Now if the width is less than length, we simply swap it so that we can have the length as LLWW in a sorted fashion. Now we have the colors, and as we saw, we can have different permutations on how we use the color. We can go with RGB, you can go with RBG, or we can go with BRG. These are the different orders that you can go for the colors. Now the same thing can be done with the length also. We can choose to go with LLWW, then we can choose to go LW, or we can first choose the both widths and then both the lengths. So for that, what we do is we simply use the next permutation function. So with this, we'll get all the different permutation that we have of our length list. Now for each of these length, what we will do is we'll go over the color orders that we have written here. So for each color order, we want to check whether we can use to cover that side. If we can completely cover the side, that is the color that we have available with us, it is greater than or equal to the length, then it would mean that it takes us a single color to color that side. If that is not the case, then we will have color that is less than the length. So we simply use it and then we choose the next color to again fill that side. Doing so at the end, we would have completely painted the fence and we'll have a value of how much color was used on each side. So if a side was filled with a single color, the cost will be 1. If it is any more than that, the similar will reflect in our cost. We do this for all the permutation of length with all the orders of our color. Whichever is the minimum answer at the end is the answer to paint the complete fence. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of length, width, and the colors. Now again, we do the same permutations that we have done on both length and color orders. Once we do this, so for each length permutation, we check all the color orders and find whichever is the minimum to be our answer. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day and I'll see you in the next video.